I'm Doug Fern, and this is my take on music recording. What does ground mean? We say some piece of equipment needs to be grounded, or an electrical noise we hear is a ground loop. You may see equipment with a ground lift switch. Your equipment may have a terminal on the back marked ground. There's a lot of bad information about grounds out there, and many of us are victims of misunderstandings. So what is ground anyway? Technically, it is an electrical connection to the earth. That implies that the earth is a conductor, and it is, sort of. The earth is like a giant resistor that we live upon. Ground, where you are standing, is different from ground a few feet away, and it is a very different ground on the other side of the world. But we lump them all together. But no two grounds are exactly alike. There is always resistance between them. The earliest practical device that used electricity was the telegraph. That was a DC circuit using batteries for power. The DC activated an electromagnet when the telegraph key was pressed, creating a click at the far end. Since the telegraph is a circuit, it must have a full path for electrons to travel out of the battery, through the electromagnet, and then return to the battery. In the early 1800s, wire was expensive to make, so telegraph systems used a single wire on a series of wooden poles between telegraph stations. The return path was through the ground. A metal rod was pounded into the soil near the telegraph equipment at each end of the system. That provided the return path for the telegraph circuit to work. It cut the amount of wire needed in half, and that worked well for many years until the growth of electrical equipment that depended on the ground path as part of its circuit became too large. Everyone using the ground as part of their circuit became impossible. The telephone system used two wires to convey voices. That was a balanced line, like we still use in professional audio today. No ground connection required. When I was a kid, I read about how audio could be transmitted through the earth for quite some distance. The system used an audio power amplifier running at least a few watts. One side of the output, normally for a speaker, was connected to the house ground, typically through the copper pipes used for water. The other terminal of the audio output of the amplifier went to a ground rod, ideally quite far away. In my experiment, the ground rod was about 50 feet away. Putting audio into the amplifier injected this signal into the earth. The receiver was a duplicate of the transmitter, except that instead of an audio amplifier, a pair of high-impedance headphones permitted the sound to be heard. How far could the audio signal travel? Well, my friend Jack and I were studying for our amateur radio licenses, and that meant learning Morse code. We needed to practice every day for a couple of months in order to get our sending and receiving code speed up high enough to pass the test. We used the through-the-earth system to communicate over the block and a half between our houses. It worked well, but the signal was weak and the noise level was high. The noise was in the form of a ground loop buzz, which I will talk about shortly. This system allowed us to practice code from our homes and ultimately pass the FCC test. It was remarkable to me that this actually worked. Another friend, who lived even farther away, was intrigued by our setup, and he installed his own ground rod and headphones. He told us he could hear us. He was over a mile away. I doubt that this would work today, but back in the early 1960s, there was far less electrical noise pollution. The noise today would overcome the weak signal. But back to grounding. Why do we persist in grounding things to the earth? There is only one reason to do that, and that is safety. It's for protection from lightning. and to prevent fire and injury from a fault in the power wiring in your home or business. Electricity arrives on two wires. Electricians call one wire hot and the other is called neutral. Those are the two conductors between you and the power plant. They form a complete circuit from which we can extract power to do what we need. There is no ground wire in the electrical grid, except for lightning protection. Ground is not needed to get power to your house. The neutral wire doesn't have to be connected to ground, but it is. In your house or business, it only connects to ground at one point, and that's where the power wires enter your building. Why? The ground connection helps prevent nearby lightning strikes from blowing up things and causing a fire. Up until the 1960s, most AC outlets had only two pins, the hot and the neutral. But people could be injured, killed, or equipment destroyed, or a fire started if there was a fault in the wiring. To provide additional safety, a third wire was added, and it was called ground. True, it did eventually connect to the earth, but so did the neutral. In fact, the ground wires in your AC wiring connect to the neutral in your circuit breaker box and nowhere else, and those two then connect to the ground where the electrical service enters the building. This connection is for safety, nothing else. But how do the neutral and ground wires connect to the earth? Through a ground rod, which is simply a copper-coated metal rod, typically 8 to 10 feet long, that is pounded into the ground where the power wires enter your building. That provides a safe path for lightning and for voltage from a wiring fault to safely dissipate. You probably never knew you had a ground rod. A few years after installation, the top of those rods tends to disappear into the earth. You may only see a black or green wire that comes out of the earth and goes inside to the electrical circuit breaker box. Does the equipment in your studio require a connection to earth to work? Absolutely not. It would not be as safe from harm if it wasn't grounded, but it is not required for anything in your house or studio to operate. However, the electrical code requires very specific conditions to be as safe as possible. So it is true that your equipment is grounded through that third pin on an AC plug. To be safe, that ground pin must be connected to the metal case or chassis of the equipment. It is a safety feature, and it is illegal in most jurisdictions to not ground your equipment that way. Everything will work just fine without that ground, but the ground connection provides an important safety benefit. To illustrate that a connection to ground is not required for electrical equipment to function, think of an airplane. It is far from ground while flying. Spacecraft are even farther. Even your car is insulated from the ground by the rubber tires. You do not need a connection to ground to make things work. An old guitar amp may have a switch on it labeled ground. Why? Well, sometimes a guitar and amp are quieter with a switch in one position or the other. That was the case back when the AC plug had only two pins and could be inserted into the wall outlet in two different ways. Modern amps use the three-wire system, which includes the ground wire, which connects to the chassis of the amplifier. The ground switch is no longer needed, but you will still find that switch on vintage guitar amps. A direct box, or DI, whether active or passive, often has a ground lift switch. One position or the other may have less noise. Why? Well, remember that all wires have resistance. Good conductors, like copper, have relatively low resistance, but it's not zero. Anything with resistance will have a voltage drop from one end to the other whenever electricity is flowing through it. The ground lift switch disconnects the DI circuit from pin 1 of the output XLR connector. It substitutes a capacitor, which provides a ground at radio frequencies, but essentially no connection at power line frequencies and audio. More on that concept later. The ground lift switch becomes important when a DI is connected to an AC-powered instrument amp, particularly a vintage amp, and the output of the DI goes into your control room equipment. There will be an unavoidable voltage drop through the wires when electricity flows through them. The longer the wire, the greater the voltage drop. If the path of the ground wires in your studio is significantly long, that voltage differential may show up as noise in the audio. To help mediate this, the ground lift switch disconnects the ground between the guitar amp and your equipment. This path is provided by the shield of the unbalanced cable between the guitar and the amp and the DI box. Lifting the ground opens the output circuit ground so no current can flow in the shield of your balanced audio cables, and the noise may be reduced. The problem gets worse generally as the length of the audio cables gets longer, and also with an increase in the length of the ground wire in the AC system. In most studios, the circuit breaker that feeds the studio outlets is different from the circuit breaker for the control room outlets. That's 2 different wire lengths from the guitar amp to ground. There could be a difference of 100 feet in length of the AC ground wire, and that wire will have enough resistance to provide a voltage drop that is large enough that the AC hum and noise is injected into the audio cables going to your control room equipment. Activating the ground lift switch will usually result in lower noise, but it might not make any difference at all. Every situation is different. The resulting noise is often called a ground loop or ground loop buzz. That's a misleading term and not technically accurate. True, there is a loop in the ground path in this example, but the noise in many other cases is from different causes. It sounds the same, but the cure is different. The ground loop term is pretty well entrenched. No harm in calling it a ground loop. Just know that it is not always accurate. One of the characteristic things about this ground loop noise is that it almost always consists of the AC line frequency, 50 or 60 hertz, plus its tripling harmonics. Those are harmonics that are multiples of 3, such as 180 hertz, 540, 900, 1260 hertz, etc., for a 60 hertz system. The level of the overtones decreases as the harmonic number goes up, giving the ground loop that characteristic buzzing noise. It is a very unpleasant and discordant sound. A properly designed and wired studio should never have a problem with a ground loop, unless it is connected to electric musical instruments. Professional audio uses balanced wiring, which cancels out the noise. Consumer audio equipment and musical instruments use unbalanced wiring to reduce cost. One of the conductors in the audio circuit, the shield of the guitar cord, for example, is part of the audio circuit. Any voltage difference flowing on the shield of an unbalanced cable is likely to be heard as ground loop buzz. We say the shield of all our cables is grounded, but what does that mean? Well, it is probably true that eventually all those shields go through various wires to the ground rod outside your building. But in this case, ground takes on an entirely different meaning. After all, there is a lot of shielded wires in an airplane and in your car, but they do not connect to the earth. In this usage of ground, what we are really referring to is a common point where all the shields are connected together. In your car, that is the frame of the car. It is sort of a reference point where everything ultimately connects together. Another source of noise is from equipment with the pin 1 problem. I won't go into detail here, but you can learn more about the pin 1 problem in the reference found at the link in the description. This is a design flaw in a lot of audio equipment. It can cause noise susceptibility in otherwise excellent gear. And again, it is a ground problem. This design flaw has resulted in a variety of methods to try to eliminate the noise that results. Using balanced power may be one solution, or another dangerous and illegal remedy is to cut off the ground pin of the AC connector or use an adapter to interrupt the ground connection. Those may help at power line frequencies 50 or 60 hertz, but it won't do much for RF interference. And remember, the RF interference may sound like white noise with a ground loop-like buzz superimposed on it. Those external solutions may make things quieter, but they can be expensive or potentially dangerous. In my studio, I do not have any kind of power conditioning at all, just simple and legal power distribution to all the equipment. I have never heard any ground loop or RF noise at all, and although all DW Firm products have a ground terminal on the back panel, I have never used it in my studio. I suspect a few customers have either. We include it for those users who have a different grounding scheme. There is also a myth that the solution to audio noise in our studios is to connect everything to a ground rod. The theory is that the noise will be dumped into the ground and disappear. This is wishful thinking at best. It could make the noise worse. Sometimes a ground rod could reduce the noise, because you have introduced additional noise that may be out of phase enough to partially cancel the noise. But it will only be a temporary improvement because anything that changes in the wiring of your studio will cause the noise level to change. And switching on and off gear or lights or HVAC cycling can also change the noise level. If you have a ground loop buzz and listen to it for a few minutes, you will hear the level of the noise and the nature of the noise constantly changing. If your studio is in an industrial area, this will be very obvious as big machinery with motors switch on and off. Even in a residential area, neighboring HVAC systems cycling on and off will change the sound of the noise. If you find that a ground rod connection does reduce your noise, you should know the rules of the electrical code. You must connect any additional ground rods to your legally required ground rod at the AC service entrance. That might improve your chances of avoiding equipment damage from a nearby lightning strike. Improperly connected ground rods can actually make your studio more vulnerable to lightning damage, and it may invalidate your insurance claim if equipment is damaged due to a nearby lightning strike or fault in the power wiring. Follow the code, or better yet, forget the ground rod entirely and focus on things that can actually eliminate the noise. Also related to this ground discussion are the connections to the shields of your cables. The shield connects to pin 1 of all XLR connectors, or the ground pins in larger audio connectors. Over the years, several different schemes have been proposed to minimize the type of ground loop noise we have talked about. One method has the cable shields connected at one end only. That should be at the control room end of the audio lines. In the days of consoles, the shields were connected to the console ground. At the far end of the cable, say to a piece of outboard gear, the shield is not connected to anything. The idea is that no voltage can exist on a shield that does not complete a circuit. That's true, and it does work, but you have to be very consistent with your audio wiring. If just one cable out of hundreds is not wired according to the scheme, the entire noise mitigation plan will be compromised. This method will not work with phantom-powered mics, since the shield is one of the conductors for the 48-volt power. Another approach is to use a capacitor to connect one end of the shield to the ground common point. A capacitor can be thought of as a frequency-dependent resistor, at least in this context. Depending on the value of the capacitor, it will be a low-resistance ground for RF while being essentially a disconnect for audio frequencies. As a side note, the resistance I referred to in a capacitor is actually called impedance, not resistance. We use the term resistance for DC circuits and impedance for AC circuits. Audio, mains power, and RF are all AC. The electronic rules change with AC, and that's why we use the term impedance to differentiate the two. Also, the shield on our cables is not to prevent AC hum from getting into the cable. The shield has little or no effect on those lower frequencies. The shield becomes more and more effective the higher the RF frequency, up to a point. You do not even need a shield for most audio wiring, although it doesn't hurt. The shield only helps protect your studio from RF interference. The telephone landlines were never shielded. They, and our audio lines, rely on balanced circuits that cancel out interference, like noise from the 60 Hz power lines. Entire studios can be built with just unshielded twisted pair wiring. But it makes sense to use shielded twisted pair balanced audio cables. And of course, all your mic lines need to use shielded balanced wires, since the shield is part of the DC circuit for phantom-powered mics. I hope this gives you a better understanding of what the different grounds we encounter in our studio environment actually mean. The key takeaway is that a connection to Earth is only for safety, and it does not reduce noise. And what the term ground means can be entirely different depending on the context. It is a shame we use this term to describe so many unrelated things. This is the last in this 6-part series about basic electronics. There are more topics I could discuss, and I may throw one in occasionally in the future. Thanks for listening. Your comments are always helpful to me. You can reach me at dwfern@dwfern.com. This is my take on music recording. I'm Doug Fern. See you next time.